Hello and welcome to the holiday special edition of a Common Prefixes Honest Majority. In every episode, our guests bring insights in blockchain and trust technologies. Today, joining us here at the Common Prefix offices in Athens is Shresth Agrawal, CEO of Pod Network. Welcome, Shresth.
Thanks, Dionysius, for inviting me here. Really glad to be sitting and joining here for the podcast.
Amazing, yeah. I mean, Shresth and I go way back and we share a lot of stories. So I think we wanted to open up the podcast by sharing some of these personal stories of where we started, how we met, and the whole birth story of both Common Prefix and Pod itself.
Definitely. I mean, the first memory I have of talking with you is I just wrote you a message on Telegram, and I was still an undergrad student studying in Bremen, and I wanted to do my thesis. I was still working in the blockchain space. I was building some smart contracts for DeFi protocols.
You were at Paraswap at the
I was
time?
at Paraswap, exactly. I was at Paraswap, and which is a DEX aggregator, decentralized exchange aggregator, and I was an engineer. I had a lot of engineering and smart contract experience, but I was very curious about how blockchains worked and how the internals of blockchain were. And I found Research DAO somehow through founder Stephen, founder of Harmony.
Yeah. So Stephen of Harmony was running with us together.
Exactly.
Nicholas here of Common Prefix nowadays, Research DAO, right? That was
exactly
a while ago.
And then I visited you at Stanford. Like after a message, you were like, "Oh, come to Stanford, and we can meet and hang out." And then I did the thesis with you, and the thesis was on building light clients and super light clients for proof of stake networks.
Right.
Which was very fun, right? We were able to build the first light client for Ethereum. Not only we did like a lot of theoretical work, but we actually implemented it out, right? And that was
work with Joachim Noy, also of Stanford at the time. He's A16Z now.
Right. It was with Joachim Noy and Nusrat Tas.
Right, yes.
And then, you kind of lured me into joining Common Prefix. That was still, Common Prefix was kind of early on, like 8-9 months old, probably.
Tiny team, 5 to 10 people maybe. Yeah. And at the time, you also, we continued working on this research. We made it even a publication, right?
Yes, paper. That was my first publication.
Yeah.
That was my first publication. I was, and then at the early days of Common Prefix, we got to work on almost like all aspects of Web3, right? From infrastructure to DeFi, L1s, L2s, on research engineering, and I was kind of in the intersection of research engineering, talking to clients, and really had a fun time. And then at some point, I guess, we came up with this thing, Pod. So we were working for the Flashbots,
right?
And Flashbots, if you guys are aware of, it's a solution to democratize MEV, and they have a way where proposers and builders they bid on who gets to include the next transactions in the block and build the block. And this is it's an auction protocol that happens every certain interval. And Flashbots gave Common Prefix a grant, trying to figure out a way to decentralize such a network and do these auctions in a fast and efficient fashion. And then, you did all the first principles thinking and kind of came up with this concept of how we can do these fast auctions. And, we were staring at the board and the protocol looked too simple for what it was doing. It was like, is that it? Like, is it a timestamping server? Like, what does it even do? How does it even, I don't know if you remember that movement.
Yeah. And out of it came a paper, of course, co-authored with Bernardo David and Orestis Alpos initially of Common Prefix, but then contributing also was Odysseas Sofikitis and Yakov Mitrovsky. Yeah. So a lot of people collaborated, and we had the opportunity to present it. But also, I mean, it's not just a paper, right? It's like full implementation as a company now. So what happened there?
Yeah, so we had this protocol, and then we were staring at it, and it seemed that it could do much more than just auctions. And the realization was that, blockchains have been kind of built in an extrapolation fashion since the Bitcoin era. We have blocks and chains, and let's just make these blocks faster and bigger and move the consensus faster. But if you kind of take a step back and then start thinking from the first principles of and come up with a blockchain with the BFT assumption, with proof of stake networks, it would actually not have these blocks and chains, and it would look much simpler and also be much more high performant if you take a lot of learnings from the Web 2 side. And that's what Pod was essentially, and is. And then we realized that this is something that should be taken as an independent company, and we raised funds with Enreason and 1KX. And yeah, we thanks a lot for the opportunity. We were able to spin out a full company, and now we are a team of 10 people. Also half of the team is based out of Athens, and we collaborate and work on a lot of great stuff. Now it's almost a year old.
More than a year.
More than a year.
More than a year.
More than a year old. Yes.
Yeah, very exciting. The race was very exciting. Talking to A16Z people.
Yeah.
Talking to everybody at SBC of that year.
Yeah.
And traveling and so on. And that also is what brought you to Athens to move to Greece, right? Personally.
Yeah. I mean, I was coming back and forth when I was working at Common Prefix, but I was, the deal that you had for me was you're gonna spin this company out, but then you should move to Athens. So I was on that deal, and to be honest, it's great. Like working in an office and working next to the co-founders, being able to also come to the Common Prefix office. Now we have a small hub here almost, right? So I enjoy it, and yeah, it's great that I was able to
somehow reaching the critical mass that now the community is happening is very, very exciting.
Yes.
So what's happening with Pod? A lot of interesting developments, a lot of scientific innovation. I heard about the club from the people of Pod, from some people on Common Prefix contributing.
Yeah.
What is it and what does it do?
Yeah. So with Pod, right, when we started, we had this kind of first principle approach of building fast decentralized networks, and the network itself doesn't have any blocks or chains or consensus, and you can like confirm transactions in one network round trip, right? And this gives you Web 2-like efficiency. And we know that this kind of technology is very good for fast auctions and payments. So we took a step back and then found what is the core application, core market that we can capture. And one of the key innovations of Web3, if you look today, is it has allowed people to start new markets completely trustlessly. So if you look at Uniswap, you can go tomorrow to Uniswap, create a token, launch it on Uniswap without asking anybody's permission, and somebody completely on the other side of the world can trade, right? But blockchains were not built for fast markets, right? They have problems of MEV. They are still slow to compete with anything like NASDAQ markets. They're not as fair because it still depends on a leader. And Pod actually started to solve this problem for Flashbots, to build fast markets. So we decided to build a very efficient, tightly integrated order book. You refer to as CLOB. CLOB stands for Continuous Limit Order Book. So order books are kind of the like fundamental behind all kinds of markets, right? If you've traded on a stock market, if you have traded on any kind of derivatives market, option market, they all run on these kind of order books, which is very simple. You place an order, somebody else places another order, and these orders gets matched. And you want these matching to be very fast and ideally to be fair, kind of protected against MEV, and I'm happy to go on more details. So we have built this very high-performant, natively integrated order book, and we believe that this is going to democratize building fast and global markets while still being fair. And this has not been done before, and this is going to be able to achieve what we are seeing now. We are able to achieve over 300K orders per second with like 100 millisecond tick times and so on.
That's crazy. Like nobody has done that level of throughput and latency before, right? This is really unique.
Yes, it's insane how much optimization you have to put in to achieve these numbers. Like it's at every level, not just kind of the protocol level, but the networking, OS, distributed systems. Everything has to be designed from first principles to allow for this amount of throughput and to achieve these latency numbers.
So we know about latency optimization and throughput. It's a very hot topic, obviously, in all of research around our area, right? Like, obviously, Sue is doing a lot of that with the line of work of narwhal shark, bull shark, narwhal, tusk, and so on, aspe, right? But obviously, like follow-up works, like simplex, like kutsu, all of these things, mangrove, right? All of these papers are focusing on latency and throughput on the protocol level. But now you're mentioning something new, which is systems level optimization, OS level optimization, networking optimization, and we didn't really have historically the protocol for these things to matter, right? We didn't have a design of a protocol where the bottleneck will become the OS or the network. So what optimizations are you guys doing there? What's the nitty-gritty of doing these things?
Great question. Let me kind of just take a step higher and say, so when you look at kind of Bitcoin or Ethereum, right? They don't even go on those level of optimizations because they have to do several network round trips, right? And network is the slowest thing, right? So we have been able to, the first critical step that we took was to be able to reduce the network round trips we need, right? And as I said earlier, you can confirm transactions in one network round trip, right? So once you have reduced that one network round trip, now you still need to process a lot of transactions on the full node side, right? Which is the bandwidth part of it. So how do you do that, right? If you have just a single thread kind of handling all of these things, right? You quickly get to a point where it cannot handle so many operations coming in. So now you have kind of multiple threads doing it, right? And you have multiple threads, but then you have state that is shared between them. Now, if you have locks that are shared between them, then the locks become slow, right? So you have to design almost like a small pod inside pod to kind of handle shared state and interaction between these threads. But also things like when you send attestations, you cannot use TCP. You have to like fit every attestation in a UDP packet, maybe even several attestations or several transactions, and so on. So we've done like a lot of different optimizations, and I think Alex, my CTO, would be like the right guy. I mean, I know from what he says a lot of really interesting things, but yeah.
So there's a Rust implementation from what I hear?
Everything is a Rust implementation.
Very exciting. And you're optimizing at the UDP level. You're making sure that you fit an exact number of orders in a UDP packet and everything, right?
Exactly. And avoiding locks. One critical thing, for example, is that storage is too slow. You cannot read or write to the storage. So everything has to be in memory. Now, if everything has to be in memory, how do you actually handle if the node crashes, right? So you almost build these systems which are replayable, right? And you have certain events coming in, right? And then if you replay these events, then you get to the same state, but you never actually put this state in the storage. You just keep all of the state in memory, and then you just make sure that you have kept track of all the events, and in kind of a log fashion, which is
very exciting because I mean we're going back to the 80s where databases did this with bin logs and streaming and replication. We're learning a lot of lessons that have been known for a while, but we never adopted them or adapted them in Web3, right? So it's good.
It's very fundamental, and most of the like basic systems don't work. Like databases cannot go to that throughput by default, and you need to build all of these, like go back to the fundamentals, look at the Web2, what they have taught us with primaries, with secondaries, with reading clients, writing clients. And like optimize at every level, which requires very kind of tight integration between protocol level engineering and systems.
And this part of pod within pod, I've heard it before, but initially it kind of confused me, right? But let me try to say it in my own words. So you have the pod network, which is a distributed system, and then each physical computer is a node in that network. But now you're saying within each node, that is, a trusted environment. Now you have certain threads, and the threads are acting as mini nodes in a smaller pod protocol that is running within the bigger one.
Exactly.
Is that about right?
Exactly. And it's like you need some kind of similar guarantees across of a single node, but inside the individual threads that are kind of sharing a certain state, they need to provide this eventual consistency guarantee. And then you run a pod, but not in a Byzantine fault-tolerant model. You run in a crash fault-tolerant model, which means that maybe your adversarial resilience is much higher. You might be able to tolerate 50% instead of 1/3. But it is kind of running a mini version of pod inside every node of pod to be able to horizontally scale. Otherwise, you cannot horizontally scale enough.
Very exciting.
Yeah.
Very exciting engineering work. So, okay, global markets that
Yeah.
are fast
Yes.
and trustless.
Yes.
Right? These are the three principles.
So it's
Fair.
global, fast, and fair.
And fair. And fair
Yeah.
encompasses also trustlessness and being able, like openness and then open participation.
Yeah, so fairness includes, like, if I'm trading in a market, right? If, let's say, I'm sitting in India and I have a decent internet connection versus somebody who's sitting in Wall Street with similar kind of network connection, should be able to participate in this market at equal playing grounds, right? So you can only win in this market by providing better prices. And this is not the case with most of the Web 2 markets. If you buy a stock on a broker, you are by default at a worse price. You will always get a worse price than the one sitting next to the stock exchange, and this is a well-known fact. Everybody knows about it. And sadly, blockchain technology is also slowly moving towards that, and that is the whole kind of concept behind MEV, where, like, a single leader gets to propose a transaction, and then again, whoever is next to the leader is able to benefit out of the user's transaction. And because pod itself is leaderless, there is no single party that can control the transactions that make it to the network. You get very nice fairness properties across auctions and batch auctions. So that's fair, but also making it global and open, which requires, anybody should be able to create markets. Anybody should be able to trade against these markets. While we want all of this to be efficient, right? So if the markets are not efficient, people will just still stay at the existing markets. So we want these markets, these global markets, to be competing with NASDAQ systems, with NYSE, right? And I think with the amount of throughput and latency we have now, we have a fair shot at it.
Very exciting. And you're focusing on this single application, which is these kinds of markets, right?
Yes. So for us at the moment, our North Star here is to capture global efficient markets, global efficient and fair markets. And this is where we are putting all of our eggs and kind of doubling down on. I think all of our current use cases are all around that. The partners we are working with, such as CowSwap, for example, it's basically intent matching, again, matching using these order book systems. We have Flashbots testing it for the rollup boost stack, again, in a similar fashion. So yeah, all of our use cases are around fast matching engines and order books and markets. So we want to just make sure that we really get that out and allow people to build these markets.
So what's the plan? I mean, I heard, or when mainnet, I guess.
Yeah, so we want to get our first beta mainnet out soon. And this will have a production deployment where people will be able to bridge tokens in, start trading, and it will use a stable coin for gas. So we want to make sure that the whole experience is very seamless, and we want to get this out very soon.
And will it focus on particular markets? Are you going to do perps, or what are you going to do?
So at the moment, the focus is going to be around equity perps. So let's say you take the top 10 NASDAQ traded stocks, you'll be able to buy and sell them using stablecoins with margins and so on. And then slowly we will start expanding new markets. We have some partners in the pipeline who are planning to release other markets like prediction markets, spot markets, and so on.
Exciting, exciting.
Yeah.
Okay, so let's talk about the future. Let's talk about the vision of pod, but also the vision for the broader ecosystem and the broader market of blockchain and trust technologies. And I want to start with one question that I have. I noticed in your mission that you don't use the word blockchain or the word Web3. You just say global market. So how did you lose the Web3 identity, I guess?
Yeah, I think Web3 is just a solution, right? And I've been in the space, you've been in the space for so long, right? And we ask ourselves again and again, right? What are blockchains useful for? And my answer to that question is that blockchains allow us to build systems which are global and open, right? So the answer to making a system global while still making it open is Web3, right? And I've moved away from the pitch of saying, this is blockchain native to this is global, which requires it to be blockchain native or Web3 native. And yeah, I think that the whole space is, if you look at the kind of use cases that we have captured, right? I think that there are two main things that have in the Web3 space that actually have found product market fit. One is fast markets or markets, right? I mean, we know that DeFi is a thing, and there is a lot of institutional adoption there, and it's clear because what DeFi allows is basically Lego blocks for anybody to build any kind of primitive, and without trusting any authority, right? So anybody sitting in China can launch a primitive that is used by somebody at JP Morgan or somewhere else in any other part of the world. So that's one. And the second part is payments, right? Payments, I think, is very clear. Blockchain is going to be, or Web3 is going to be the substrate for doing global payments. Again, global is the key thing here, right? We have payments, right? If you look in Europe, we have payments, but then the moment you want to do, sitting in Nigeria, do a payment to somebody in China, you cannot do it, right? And that is what is the key value addition, right?
Or you cannot do it fast, let's say. Or
you cannot do it fast or efficient.
Or fairly.
Exactly.
Yeah.
You will have like so many intermediaries, it will take you days to get, and you will get half the money.
And anybody can censor you in the middle.
Exactly. So I think those are like the two things that I definitely see them taking a lot of, like we will realize that a lot of Web3 protocols will double down on these things and make Web3 infrastructure that's more opinionated towards more on payments and markets than other use cases that we've been thinking.
So what do you think the broader industry will do in the next 2 to 5 years? What's the next hot thing, I guess, in 26 and 27?
I think it's just people will start realizing that this infrastructure has got to a point where it's useful, and then day-to-day users will have applications that is using it without them knowing about it, right? And this is critical because at the end, it's just a global database, right? It's a global database that anybody can read and write to as long as they follow the rules, and end user doesn't have to know. But the moment it is in the hands of end users, right, it will enable a lot of global applications, and things will just become smoother for the end user. So what I'm really hoping to see in the next couple of years is to see more applications that use Web3, which not for the sake of it being Web3, but for it to provide value to the end user, and a lot of bigger institutions kind of adopting it and using this technology to build up the stack, essentially. Yeah, so I'm really excited about that.
Yeah, likewise. Anything else you want to add about Pod, about the market, about everything that's happening around us?
No, I think it's a great time for everybody to be building, and I feel like we are getting to this inflection point where Web3 is starting to make sense in a lot of different ways, and once this now we're seeing a little bit of the bear market, a lot of let's say the trashy projects will be faded out, and we will see more of the good fundamental projects coming out strong and building good user-centric applications. So keep building, and I'm really excited. Hopefully you will try out Pod, send us your feedbacks. And
so we'll add a link in the show notes below. Where do people try out Pod today?
Just go to pod.network. You will find our docs, our websites, a lot of material. So
just go to pod.network. We'll have a link in the show notes.
Yes.
With everything, and you can find everything there. Okay, Shresth, thanks so much for joining us today. It was great to have you.
Thanks a lot for inviting me. This has been amazing. So
yeah. And that's all for this episode of Honest Majority, the holiday special. We'll see you all here next time.